Hi everyone, this is question number 25. So we need to find the gradient of the tangent for each of the following curve at the given point. So let me just simply sketch any curve. So this will be our y equals to 2x squared plus 3 raised up to the power of 2. Now this is in the form of u to the power of n, yeah? Okay, and next what we want is to find the gradient of the tangent. Let's draw the tangent first. Tangent is the straight line that passes through the curve at only one point. So let's mark down the point as well, P125. Okay, so these three are the important stuff that we need to find the gradient of the curve. Okay, so what we want is to find the gradient of the tangent at this point P. So we know that mt basically is dy by dx. So the first thing is to differentiate the y given. So dy by dx will be, since this is in the form of u to the power n, so we apply the chain rule. So we have 2, all right, left with power 1, do outside, and followed by do the inside. The inside will be 4x. Okay, let's write properly. This is 2x squared plus 3, yeah? Okay, 2x squared plus 3. Okay, and next, that is the gradient function. If we want to find the value of the gradient of the tangent at that point, we just need to substitute the x value. X coordinate is 1 here. So the gradient of the tangent will be substituting x equals to 1 into the gradient function. So we have 2 plus 3 and then 4 times 1. So let's multiply everything together. 4 times 2 is 8. 8 times 5 is 40. So the gradient of the tangent at point P is 40. So part 8 done. Part B, the same thing. We have the curve and then we need to find the gradient of the tangent. This is the tangent. We are looking for the gradient of the tangent and passes through the point P, 2, 8. So this is the y equals to 4 minus 3x squared over 3 minus 2x. So this is the quotient form. Okay, so we use the quotient rule. So dy dx will equals to stay v, 3 minus 2x. Differentiate the u. So when we differentiate the u, we will have negative 6x minus stay u. Okay, 4 minus 3x squared. And differentiate the v. So when we differentiate the v, we have negative 2. And don't forget to over the v squared, 3 minus 2x squared. Now, if we were to find the gradient function, we should factorize this. But since we are looking for the specific value of the gradient, we can just substitute the x value in. So the x coordinates of the point that we pass through, that is x equals to 2. Therefore, dy by dx equals to 3 minus 4. 2 times 2 is 4. And then negative 6 times 2, we have negative 12. And then minus negative with negative 2, so become plus 2 times 2 squared is 4. Okay, 2 squared is 4. 4 times 3 is 12. So 4 minus 12, we have negative 8 here. Over 3 minus 2 times 2, 4. So negative 1 raised up to the power of 2. Okay, so over here, this is negative 1. So negative 1 times negative 2, we got 12. And then minus 16 over 1. So the answer is negative 4. Okay, so that's it for question number 25.